In this section, we will model stock return using normal random variable and demonstrate the importance of distribution in identifying financial risk. In the risk management aspect, it is important to know the distribution or model for stock return. We need to compute what's the chance that the yearly return drops over 40%, and identify whether it is just an extreme case. We will compute the log daily return for the stock price of Microsoft. The histogram of a return is symmetric and bell-shaped, which is very similar to normal distribution. We can get a density function and a cumulative distribution function using script, which is a scientific computation package of Python. We can use norm.pdf to get the probability density function. In fact, a normal random variable can take values from positive infinity to negative infinity. Here, we get the density between the minimum value of log return of Microsoft minus 0.01 and the maximum value of log return of Microsoft plus 0.01. Two parameters mu and sigma in norm.pdf represents the mean and the standard deviation of a normal random variable. You can change these two values in order to get a different normal variable. Because the density functions of normal variables are only related to their mean and their variance. We can get the graph for normal density, symmetric with a mean and symmetric center. It is also bell-shaped. We can use the normal distribution to model daily stock returns. It is not necessary to know the real mean and standard deviation of this normal random variable. We have a large collection of data returns from historic data and use them to compute the mean and the standard deviation. They are not the same as those of normal variables, but you can see from the picture. They are close enough. Then, what is the chance data loss can be more than 5%? We can use CDF to get this probability, which is 0.017%. So we have 0.017% chance to have a daily loss of more than 5%. Our goal is to find out how likely that the stock price of Microsoft was dropped over 40%, 1 year which has 220 trading days. We will use another normal distribution to model yearly returns and figure out the mean and the standard deviation of a yearly return. We make a wrong assumption that the daily returns are independent to simplify our example here. To get the mean and variance of a year's return, we have formulas for the sum of variables. We need independence when we compute the variance. If the data return independent, the variance of a unit return is equal to the sum of the variance of 220 daily return. From these lines of code, there's only less than 0.29% chance to have the yearly loss to be more than 40%. In real life, we need to solve a different type of problem with distribution. For example, finding quantiles of a normal distribution is a common task when performing the statistical test in financial risk management. We can use norm.ppf to find normal distribution quantiles. ppf stands for percent point function. In finance related to the quantile, there is an important risk measure value of risk or VAR, which estimates how much a set of investments might lose with a given probability. VAR is typically used by firms and regulators in the financial industry to gauge the amount of assess needed to cover the possible loss. For example, 5% of the quantile of daily return is called a 95% VAR or VAR at the level of 95%. We can use a ppf to get a 5% of quantile, which is negative 0.0225. So 95% of VAR is negative 0.0225, which means with a 5% chance that daily return is worse than minus 2.25%. Is it safe to use a normal description to model stock return? According to Fama and French, distribution of a daily and monthly stock return are rather symmetric about their means, but the tails are fatter. This means there are more outliers that would be expected with normal distributions. It means that, if tail returns negative, as well as positive, may occur more often than we expect. If we use the normal distribution, this is debatable, at least for the returns of some assets with different time window size. To model a fat tail, people proposed modal return using t-distributions with a low degree of freedom. We will talk about and use t-distribution in the next several sections. In the next section, We will talk more about statistics in week 3.